Today's lesson is going to be on the triangle inequality and the converse of the Pythagorean theorem. Okay, we're going to start with the triangle inequality. It says that the sum of any two sides of a right triangle is always larger than the third side. Okay, all that means is that if you have a right triangle, like the one here, and you add up any two sides, that sum is always bigger than whatever the third side that's left over is. Okay, so like, say you're looking at side AB. The length of side AB is always less than the other two sides added together. So whatever AC is, plus CB. Okay, if you pick a different side, you start with side AC. Side AC would have to be less than those other two sides, which are AB added to CB. Okay, and finally the third way to write it would be with side CB. Side CB would have to be less than those other two sides added together, which were AC and AB. Okay. Now let's apply it. Go ahead, slide down to the first example. It says, could these be the lengths of the three sides of a triangle? Okay, so the first one, it says the sides are 2, 3, and 4. Okay, the easiest way to check if those three sides could make a triangle is to add up the smallest two sides. If the two smallest sides are bigger than the third side, then you know it could be a triangle. Okay, so the two small sides, for example A, are 2 and 3. So 2 plus 3, that's 5. Which is in fact greater than 4. So yes, this could be a triangle because the two smallest sides are longer than the third. If you look at example B, the two smallest sides are 5 and 3. 5 plus 3 is 8, which is actually less than 10. So this one could be a triangle. If you had sides that were 5, 3, and 10, 10 would be the longest side, 5 would be small, and 3 would be small, and there would be no way to stretch 5 and 3 to meet the length of 10, because added together they're smaller than 10. Okay, go ahead down to the bottom one. Find the possible lengths of the third side of a triangle if the other two sides are 5 and 12. Okay, so this is still going to use the triangle inequality, just know that the two sides are 5 and 12. Okay, so say those two sides are the two smallest sides of the triangle, and the third side we don't know is actually bigger than those two. That would mean that x, the unknown third side, would have to be less than the two smallest sides added together. Okay, so say the third side is x, 5 plus 12 is 17, that means the third side would be less than 17. Okay. However, x might not be the biggest side. It's possible that x is the smallest side. In that case, the biggest side would have to be 12. And 12 would have to be less than whatever x plus 5 is. Okay, if I simplify this inequality, subtract 5 on both sides, that means 7 is less than x. Okay, so based on these two bits of information, x is greater than 7, x is less than 17, I can write that as a single inequality, that x could be any number between 7 and 17 in order for this to make a triangle. Okay, head down to the next part. Number 3. Find two possible side lengths of the third side of a triangle if the other two sides are 8 and 13. Okay, let's go with the same assumptions here. It's possible for x to be bigger than both 8 and 13. Okay, so x could be the biggest side. For that inequality, x would have to be less than whatever 8 plus 13 is. So I go ahead and simplify. 8 plus 13 is 21, so x has to be less than 21. Okay, for my other inequality, I want to assume that x is actually the smallest side instead of the biggest side. Okay, if x is the smallest, then 13 is the biggest. So 13 is less than x plus 8. Okay, and if I simplify this, I'd subtract that 8 from both sides, end up with 5 is less than x. Okay, so what this tells me from these two separate inequalities is that x has to be between 5 and 21. Whatever the unknown side of the triangle is, it's between 5 and 21, and that would make those three possible sides make a triangle. Okay, next for the converse of the Pythagorean theorem. Okay, we learned the Pythagorean theorem before, which says that whenever you have a right triangle, a squared plus b squared equals c squared. Okay. The converse of the Pythagorean theorem tells us a way to figure out whether the triangle is right, obtuse, or acute. Okay, so what this says that if you compare a squared plus b squared ends up being less than c squared, then the triangle is obtuse. If a squared plus b squared is greater than c, the third side squared, then the triangle is acute. Okay, so all I've got to do is compare those three sides, and that will help you figure out whether the triangle is right, obtuse, or acute. Okay, check out example 4. It says, are the following triangles obtuse, right, or acute? So we have three sides given. Always pick the two shortest sides to be a and b. So like 4 would be A and 5 would be B. The longest side, the C, is going to be a 6. Okay, because think about it in a right triangle, the hypotenuse is always the longest side, always side C. Okay, so when I compare A squared plus B squared, that's like comparing 4 squared plus 5 squared with 6 squared. Okay, so what I want to figure out is which side is bigger, or are they the same? Okay, so you might need a calculator to simplify. 4 squared is 16, 5 squared is 25, 6 squared is 36. 16 plus 25, that's 41 compared to 36. Well, 41 is bigger than 36. And no, that makes this example 3, a squared plus b squared is greater than c squared. That makes this an acute triangle. Okay, so anytime you have a triangle of sides 4, 5, and 6, it's going to be acute, meaning all the angles are less than 90. Okay, the next example is very similar. 7, 8, 14 are the numbers. The two shortest ones, those are going to be sides A and B. Okay, so 7 and 8 are A and B. 14 is going to be C because that's the longest one. Okay, so I set up 7 squared plus 8 squared compared to 14 squared. And then I start simplifying. 7 squared is 49. 8 squared is 64. 14 squared is 196. Okay, and then you need to add the 49 plus 64. That gets me 113 compared to 196. Well, this time 196, the right side is bigger. When the right side is bigger, that makes it an obtuse triangle. Okay? So based on this theorem, all you need to do is check if a squared plus b squared is larger than c squared, or a squared plus b squared is less than c squared, and that's going to tell you whether the triangle is acute or obtuse.